All right. By the way, before we get into it, another teacher that will be in here with me, so you already know her, is Miss Davidson. All right, she's co-teaching this class with me, so if you have a question, you're also free to ask her as well, especially if I am busy with someone else. Feel free to ask her. All right. All right. So, like I said, this unit is all about geometric transformations. A big part of math too is geometry. Okay. Now, geometric transformations, in my opinion, is fairly straightforward. All right. It's a lot of just moving up and down, left and right, flipping, rotating, stuff like that. All right. So now we can start to explore rules that govern physical space in a flat plane. So by flat plane, I just mean a coordinate grid. All right. So first off, let's talk functions. Okay, you've been learning this since math 1. You've been learning this even in middle school. So a function is a rule often given by an equation that converts or maps an input into a single output. Now, does anyone remember from math 1 what part of a coordinate an input is? So in a coordinate, what are the two pieces of a coordinate? X, Y. So input would be the what value? Just take a guess. What do you think? You can just say it out loud. It's X. All right, so your input is X. That's what you put in. All right. What do you guys think the output is? Y. So X is what you put in, Y is what you get out of it when you evaluate. So for the first example, they give us this function f of x is equal to x plus 5, and they want us to find the value of f of 4. Now, look at the difference between f of x and f of 4. All right. What did the 4 replace the f of x? The x. So what do you think I'm going to do with this 4? Plug it in for x and solve it. All right. So if you ever see a problem like this, it's the easiest thing you do. Take whatever number's in there, plug it in for x. There you go. So x is equal to 4. So we're going to do f of 4 is equal to 2 times 4 plus 5. Now, if I'm talking order of operations, what do I do first? So PEMDAS, it's also on that poster over there. What do I do first? All right. There are parentheses, but technically these parentheses are dictating what? What operation? Multiplication. All right. So if you ever see a single number around parentheses, it just dictates multiplication. All right. So I do the multiplication first, though. So what's 2 times 4? 8. And then I add it. So plus 5, 13. So f of 4 is 13. So if I were to write this as a point, this is actually my y value. So if this was a point, this would be the point 4, 13. So if I looked at this function on a graph, one of the points on that graph would be the point 4, 13. All right, that's what input output means. Okay? Now, why is this important? In transformations, you will see what's called arrow notation. All right, arrow notation is just written as a function. All right, fairly straightforward. It's just you're going to be doing exactly what we've been doing. Plug in whatever value they give you, and then go from there. Okay. So now we're going to look at functions where the input is a coordinate point and the output is a coordinate point. So they're saying that for the rule f x, y, so if we're given the point x, y, so some point, then that would be our new function when we plug in for x and y. Now that looks like a lot. It's actually fairly simple. All right, so let's do an example first off. So if I'm given the point 2, 7, all right, so this would be my x, y. All right, this is my input technically. So what do you think I'm going to do to get my output? Right. Plug them into x and y respectively. All right. So this is my original point, x, y. So what I'm going to do is I'm going to plug this number in for this x and this number in for this y and evaluate it to get the new point. So what this would look like is 2 plus 5, because it was x plus 5. That's our first coordinate. And then 2 times 7, because it was for 2y. That's our second coordinate. So what's my new point? So what's 2 plus 5? So that's my new x value. What's 2 times 7? 14. So that's my new y value. So this is my new point. So instead of getting a singular number as my output, I'm now completely getting a new point. Now, why is this important? Like I said, most transformations, so translations, rotations, dilations, reflections, they're written as some form of rule like this. All right? So if you're asked to graph, all right, but you weren't given a graph that you can actually look at it and, just see it, you can do it like this. Just take whatever point you start with, plug it in for the x, y, and the rules, just evaluate it. Everyone following so far? Any questions? All right, let's do another one. All right, walk me through. What am I doing? Someone who hasn't talked yet. So what's my first step? We're just replicating what we just did with letter A. So we're going to take the -1 and do what? Plug it in for x. So I have -1 plus 5. What do I do with the 0? Plug it in for the y. So I have 2 times 0. Take them in, evaluate that on your own, get the new point. All right, someone raise your hand, tell me what they got for their new point. Someone who has not talked yet. So you got 4, what? Not 2, because what's 0 times anything? 0. So it's 4 0. So -1 plus 5 is 4. 2 times 0 is 0. So this is my new point. All right, try letter C and D on your own. I'll give you about 2 minutes. Remember, all you're doing is plugging in for x and y. All you gotta do. Thumbs up if you're ready. I'll give you 1 more minute. All right, so someone raise their hand and tell me what they did for letter C, someone who has not talked yet today.
Do you want like the whole steps I did?
Sure, go for it.
So I plugged in the -3 into the xy.
Mm-hmm.
-3 plus the 5. And then I plugged the 3 into parentheses with the y equals 2 parentheses 3.
Uh-huh.
And then I did negative 3 plus 5 equals 2.
Mm-hmm.
And then 2 times 3 equals 6.
Good. Good job. So your new point is the 0.26. How'd y'all do for letter C? Did pretty well? All right. Someone else. Letter D. What'd you do? Go for it.
I'll put the y in for the x is negative 6.
Uh-huh.
My final answer is 13.
Good. So 8 plus 5 is 13. 2 times negative 1 is negative 2. Any questions on exercise 2? So again, fairly straightforward. You're just plugging and chugging. All right. Plug it in. Do the operation. Get the answer. All right. That's all it is. Pretty straightforward. Not too bad, right? All right. Exercise 3. Very, very similar. But look at what happens. So this is our original. So if we're given the point x, y, this is what we turn it into. So someone explain to me what happens. So the x and the y flipped. What else happened? The x became negative. All right. So think about that as we do the next example. So for letter A, what do you think my first step is going to be? Flip the x and the y. So I'm going to start by just switching places. So 3, 5. What's the other thing I got to do? I got to make the x value, or the original x value, negative. So make that negative. So in other words, guys, what should happen is whatever point you started with, when you finish, it should look like this. Okay? So it doesn't matter what order you do it in. You could have made the x negative right off the bat and then flipped it. It doesn't matter. Okay? So my final answer would be 3, negative 5. So what we did, just to kind of put into words, we flipped x and y and made x, or flip the sign of x. All right. Let's try letter B. Walk me through it. What should I do?
You should flip that x and the y first.
Okay, so that'll give me negative 2, 7 if I flip it. Then what do I do? Make the 7 negative. So make the original x negative. So this would be negative 2, negative 7. All right. We're going to walk through the last two together because we're running low on time. All right. Next one. Someone tell me what to do first. Someone has not talked yet. Flip the x and the y. So what do I get if I flip it? 0, negative 4. Then what do I do? Make the 4 positive. So that's why I said flip the sign, not just make it negative. Because technically what we're doing is 0, negative times negative 4. What's a negative times a negative? Positive. So that's why I said flip the sign, not just make it negative. Because technically we did make it negative, but in reality we had to flip the sign. All right, last one. What do I do? Flip. So I got negative 5, 5. Then I do what? Make the 5 negative. So any questions on how you read this type of rule? This is called arrow notation. Or how to evaluate it. Any questions on that? All right. So we're going to stop here for today. We're going to pick up with this tomorrow. All right. So don't pack up just yet. Let me give you guys some instructions. All right. So your homework for tonight is just to get that syllabus signed. All right. what I need you guys to do is keep the patty paper because you're going to want it for the rest of this unit. If you think you're going to lose it, feel free to put your name on it and put it in the turn-in box before you leave. All right? Now, also, if you could take the name tag that's on your desk and put that in the turn-in box as well, that'd be great. All right, so you guys can go ahead and pack up. Again, take your name tag, put it in that black turn-in box by the door. And if you think you're going to lose your patty paper, you can put your name on it and put it in the turn-in box as well. Also, kind of look at where you're sitting. This is where you will sit tomorrow. All right, just until I learn y'all's names.